complicated, but there on the website there's a link to Phineas and Ferb PowerPoint that's kind of funny and fun to work with. And no, it's SpongeBob. There's a SpongeBob PowerPoint on mixed numbers that's really helpful, so you can click on that. But on 7/3, I saw Noah draw something like this today. He drew a whole piece that had a whole circle that has 3 pieces. He did it again. And he did it again. And I saw him draw 7 of these. 7 1/3 pieces. And then another way of saying that, he has 2 holes and 1/3 of another. So that was kind of easy. And they did the same thing for these. There are some 6ths. Oh, 15/6. We could draw it just like this. There are 6/6. That's 12/6. And there's 15. So there's 15 total pieces, and they're all 1/6. So 15/6 is the same as 2 holes and 3/6. Another way to look at that would be 2 1/2 also. Okay, I'm going to switch to the back. This was pretty easy. This hexagon was 1 whole hexagon. Someone had drawn on it already. But someone could see the triangles inside of it. So the triangles are 1/6 of the whole. So there's 1 hole. So that'd be 1, and each one of these is a 6. There'll be 1 hole, 1, 2, 3, 4. 1 4/6. Now, these are also 6. And if you draw a line there, you can see that. So this would be 4/6. Okay, now these were really easy. 1/4 and 3/4. When you add them together, all you do is add the numerators together when the denominator is the same. So 1 plus 3 is 4. This stays the same. This is the only thing that's a little bit tricky. You have to change the third to have the same denominator as this. So all we did was kind of like what we did on the first page. Here is multiply it by a number so that the denominators are the same. And we get an equivalent fraction. So 1/3 times 2 is 2/6. Now we can go 1/6 plus 2/6. And that's 3/6. Pretty cool. Okay. This is one people miss often because I put the subtraction way over here. I don't know what I was doing. And that won't work if we have to borrow. Let's get rid of that one. Okay. On this one, we do the same thing. We got to change this one. Now we're just adding 5 and the 2, and we get the denominator stays the same. Okay, today Alexa figured this out. All she did was, well, she could tell by looking at them which were bigger for most of them, but she also did the trick with the calculator where she took 2 divided by 3 on her calculator, and she got this. And then she took 3 divided by 9 on her calculator and got this. And so once we had a decimal, we could compare them a little bit more easily. Another kid was doing this. They took 2/3, and to compare them, he changed the denominator so that they're the same. So he did this, and he got 6/9. And then he knew it was that also. That was another way to look at it. Or a 9/15 and 1/2. We know that this is going to be that when we divide it on the calculator, because 1 divided by 2 is going to be a half. Now if we did 9 divided by 15, it's going to be more than a half. Half of 15 is 7.5. So this is more than 50% or more than half. So we know this is going to be like that. So you can use the calculator trick or use some just logic for those. There was a great video that Matt and JC and Gavin did for this. Okay. All you do is estimate, and estimate means you're going to have to guess, but a reasonable guess. And you can kind of see that this looks like sorry's about 25%. I think it's a little less. If you look at sorry and cards, it almost looks like the total is going to be 50%, but it's a little less. And cards looks a little bit less than that. Looks like 21. Risk looks like 25. Life looks like less, looks maybe like 20. And see what other is. A trick that I do is I add these up to see how close they are to 100% or one whole, and whatever's left I put here. So if we did 24 plus 21, that's 45. That'd be 70. This would be 90. So if this was 10, all this would be, and that looks pretty good actually. So if that's 10, this is 24, 21, 25, and 20. The nice thing to do is always check to see if this adds up to 100%, or one whole, because that's one whole circle. So this is one where you have to draw your own circle. It says 35% of kids liked basketball. So 35% is kind of like a third. And when I would draw thirds, I always think of a peace sign. And this is how I draw it. Now if I was drawing another third, I would have put it here and made a peace sign. So here we go. That's a third, so put basketball. And then 25% is baseball. That's kind of easy to do, because we know it's like one of those quarter pieces. Oh, that's easy. 25% for soccer. So now we got 35, 25 is 70, that's 90, see, 50, 85, oh, 10 for hockey, and 5 for other. That should add up to 100%, see. 35 plus 25 is 60, 85, 95, 100. That looks about right. These questions are hard. The first one's easy. If 100 students were surveyed about these sports, that means 25 out of 100, 25 out of 100, 10 out of 100. So all of these can be converted. If there's 100 people surveyed, you could change them to a fraction just like this. But hardly ever our survey have a nice number like 100. So this is where it gets a little bit more confusing. If 10 students were surveyed, how many of them chose hockey? Well, we had 10 out of 100 chose hockey. But now they're asking, if you only asked 10 kids, how many would choose hockey? Then you got to find the equivalent fraction for that, and it would be really easy to do. How do you change 100 into 10? What operation you have to do with division? You divide it by 10. So 10 divided by 10 would be 1. So the answer would be, if you only ask 10 kids how many liked hockey, only 1 out of 10 would get it. Okay, and now if 50 students were asked about basketball, we know that 35 out of 100 like basketball, but all we have to do is divide it by 2, because it's asking us how many would like basketball if you only ask 50 kids. And it would be half of that, which would be 17 or 18. It's just another way of finding an equivalent fraction and thinking about it.